Hello everyone, we are the group Meninas Superpoderosas e Macaco. And today we're going to present our partial and project that is Pitch Pro. And our team is confirmed by Erica, Marcus, Milan, and me, Patrick.
Hello everyone. Currently, the exponential growth of digital images has created a critical need for tools that can analyze and transform visual data automatically. So, traditional approach faces significant barriers such as slow manual processing, lack of scalability, and a total absence of real-time feedback for the user. It is within this context that we present PixPro, an intelligent platform designed to automate complex visual workflows through artificial intelligence. So our value proposition focus on providing a scalable and reliable solution for creators and enterprises. As core functionalities, PixPro delivers intelligent processing with um, selectable AI models, batch uploading, and real-time status notifications via WebSockets. Regarding the people pillar, our ecosystem is divided into three profiles: the registered user, who has full access to project management and history; the anonymous user for limited exploration; and the administrator responsible for technical monitoring and infrastructure health. To support these operations, our platform utilizes a React API with TypeScript on the front end and a microservice architecture with a Node.js API gateway on the back end. Asynchronous event orchestration is handled by RabbitMQ, ensure that heavy process decks never block the user experience, and we employ modern patterns such as event-driven architecture, CQRLs, and event sourcing to ensure system consistent and scalability. For the supported by PostgreSQL for transactional data and reads to high performance caching. And our development is governed by the Scrum framework, featuring weekly cycles and ceremonies like planning, dailies, and retrospectives that ensure transparency and continuous improvement. So for source code management, we apply the Git flow model to maintain security production releases through isolated feature and develop branches. Our entire integration process is automated. We use GitLab CI with Docker Compose to orchestrate our containers, ensuring absolutely parity between development and distributed testing environment. Furthermore, we have established a rigorous quality bar, including mandatory code reviews and a minimum text coverage of 65% measures with jest.
And this first diagram I presented the manual case of the picture before. The idea here is to show how interact with the system and which feature each actor can access. We have three main actors: the anonymous user, the registered user, and the administrator. And the anonymous user has a more limit in interaction. They can create an account or login to get full access to the platform. The registered user in the main actor of their system. They can organize projects and the categories, upload batches of images, configure and receive AI processing, receive notification through WebSocket and then download or share the results through the CDN. Uh, we also have the administrator who is responsible for monitoring logs and the platform infrastructure. Uh, we have this cipher level 1 diagram. This diagram shows Pixpro from a more general perspective, without going into the internal details of the architecture yet. The goal is to answer who uses the system and which external system does it communicate with. Uh, he Pixpro appears as the central system. The registered user accesses the platform to login, upload the images, follow the processing data, manage projects, and the access results. The anonymous user can create accounts. The administrator monitors metrics and the platform operation. We also have two important external systems, the CTN and the AI engine. The CTN represented the layer responsible for starting and distributing the process of fire security. The AI engine represented the artificial intelligence engine used to run the image processing model. And our current project at the start path is technically represented by many IO project starters. IO the city and appears at the planet layer of this night delivery and production. The AI agent is related to the image processor service which performs the AI processing. He we have the C4 level 2 diagram, which show the main contents of our project. The user accesses the front end spy built with the React and the TypeScript. This front end does not communicate directly with all steps and it goes through the API gateway, which centralizes the request and forwards which on the correct service. Uh, Authentication routes to go to the authentication service, which is responsible for registration, long and the token generation. Project how to go the project service service, which organize project image and the history. Website MK works the events bus of the architecture. It is allows the image processing to happen synchronous. The image processor service, which represents the data that consumes this task process the images and they publish the state events. Finally, the works sock the channel since he'll time update the front end. Persigue xcal start and the main data. Why with this and the CDN appears of the optimization layers of the reader data and the delivering file. Uh, this diagram show is image processing of the from beginning to end. First, the user requests the process through the front end send the request to the API the gateway which resisted the request and publishes a task to have it in here. After that the processing happens asynchronously. The image processing receives the custom and the text from the query. It runs the AI model, and it serves the processing image. When processing finish a completion if event it pushes. This event triggers the web socket, which is send a notification the different channel. With this, the user receive the status update without needing the reload page. Or in our correct code, this rule mainly related to the upload endpoint webend indicate the processing service and the software IO, which is used for real-time updates. Uh, this is a slide explaining the events delivery architecture of the project. The main idea is to prevent service from being directly dependent on each other. Instead of processing everything in a single request, the API gateway publishes and messages the reverend where when the user uploads an image. Then the processing service consumes this message performs the AI processing and publish a new event informing that the image was processed. This event is used by the notification service to notify the front end through WebSockets. Uh, with this approach, the system becomes more scalable and more decoupled and more responsive because the user receives a quick responsive IO the processing continues in the background.
Now I will talk about the quality and best practices in our project. So, first, to keep the system stable and reliable, we use automated testing and strict quality rules during development. So, for testing, we use Jest to run unit tests and integration tests in our TypeScript environment. We also monitor important metrics such as line coverage, function coverage, and branch coverage. This helps us protect the main business logic and avoid future bugs or regressions. Another important point is our merge and integration process. But the develop and main branches are protected. Before any merge request is accepted, the code must pass and fair code review. In addition, all automated tests must pass successfully in the GitLab CI pipeline before the integration is allowed. We also define a minimum code coverage threshold of 65%. And if the project does not reach this value, the rule is automatically rejected by the pipeline. These practices help us maintain code quality and system stability during all sprints. And well, besides code quality, documentation is also very important in our project. We treat the documentation as a living artifact that is updated every week according to the project progress. Our documentation is centralized in the repository wiki, making it easy for all the team members to access information quickly. We maintain several important artifacts. First, we use C4 diagrams to represent the architecture of the system, including the API, gateway, microservice, RabbitMQ, and external service. We also document our proof of concepts, including AI integration tests, broker behavior, and web sub latency results. Another important practice is the use of architectural definition reports. These documents explain important technical decisions, such as why we use CQRS and event sourcing. And well, this helps new developers understand the project more easily and keeps a history of our architectural decisions. And finally, talking a little bit about our current process. At this moment, we already implemented the authentication system, project managing screens, responsive phone interface, image upload workflow, and image builders integration. We also implemented website communication, private MQ messaging, Docker environment configuration, and the GitLab CI. And now, Marcus is going to present our demo.
Hi there, my name is Marcus, and today I'm gonna present our demonstration called PixProd, the system that you can transform your image using an AI model. So in our homepage, you can log in, for example. I don't have a account ready, so I need to sign up for free. Here, pass my name. After that, my mail, password, and get started. And here we can see our main menu. So I'm gonna create a new project and I will name demo and select any category, media for example. And here we can see that we can upload some image, and in here we have our AI process options. I'm gonna select some image. One. So I want to remove the background, so I can select in here, add image, and I can see that the image disappear, but actually here processing. If I click on that, I can see before the processing and after that processing. I can see the backgrounds removed. So I'm gonna pick another image, for example, this one, and try to upscale resolution. So the same process. Here I can see the status, and after that this is process or fail, for example. We're informed about that. So the image already processed, so I can see the compression about then. So we can see in the RabbitMQ our queues. So we already have 3 items in our queue, and let me try to stop our queue and see what happened. So I'm gonna stop the notification service and back to here, try to process another image. I pick this one again and try to enhance quality and wait. That's not stopping the main function of our system, so the process continues, but we already have some different notification in our queue process if I select the RabbitMQ. So I can see there is a notification waiting notification in this queue specifically. So if I restart the process, I'm gonna start the service. Back to here, maybe refresh the page. I can see this notification go to the process queue. So the min IO, gonna have to update again. See our bucket specifically, and here we already see our bucket. So we have two main different kind of files: the project files, basically the raw files, the raw images, the process one. So the process is when our model generates some image or process that image, and the project we can see our image and the raw image, for example. So if I'm gonna click on the preview, I can see that's one of the raw images. So let's go back to process one, and we can see the process runs it and my style. Let's try to what happened the queue. Want to remove background, one the quality. So now I'm gonna see this data. This one's our processed image. See all the information here, for example. Data related to read models, So in here, for example, we can see and we can take, for example, process link. So I think that is our progress related to this project, and I hope you like, and see ya.